Okay, good, good, good. So that is what. Let's try to understand.
Yes,
I,
sir.
hmm. So if you see the long form periodic table, here is long form periodic table. So some basic criteria is there. What are the basic criteria if you talk about, like number of period is there, okay, then number of groups are there, okay. So if I will
Yes,
ask,
sir.
that is how many period are there, so period are 7. If I will ask, that is group, how many group are there, so group are 18. These are
18.
there. Now see,
Yes.
this I think we only draw the periodic table. We didn't discuss in much detail, na characteristic we didn't study. We study any idea about that? We study the characteristics of the modern periodic long form periodic table.
Yes, sir. Yes, sir.
What we study? Can you tell me any point of that?
Like, sir, they are placed according to their groups.
According to
Like,
atomic number, they are
because
placed.
according to their atomic number and their means like families,
Hmm.
boron, carbon,
Okay, okay, good, good.
like
Thank
that.
you. So let's try
Yes,
to
sir.
little bit more here. Let us try to study. Firstly, that is what character. Firstly, you try to understand period. Period. So that is these or you can write there are 7, okay, 7 horizontal. This is horizontal in bracket left to right, left to right rows, horizontal rows, rows, rows in this periodic table, in this periodic table, which are in this periodic table, which are known as what, which are known as period. Getting, means that is left to right is known as period. Up now the second point is characteristics of period, that we need to understand characteristics of period. So if you talk about the characteristics of period, some characteristics are there. Let's see. If you talk about the period 1, period 1, so period 1, their name is the shortest period. This is known as shortest period, right? Period 1 is known as shortest period. If you talk about period, which period? Period 2 and 3, okay, that is known as short
Yes, sir.
period. This is known as short period. If you
Short
talk
period.
about the next one, period 4 and 5,
Long waiting
this is
period.
period 4 and 5. This is called long period. If you see, this is the long period. And next one, period. Earlier one period was the 7 number is incomplete period, but nowadays it got completed. So period, if you talk about 6 and 7, they are known as longest period. They are the longest period. Now let us try to understand shortest period. How many elements are there? 2 element. Okay, this is having only 2 element. Here is short period. If you talk about, this is 8 element each, 8 element each. You need to memorize this one, 8 element each. Okay, short period means 8 element each. Long period means 18 element each. Okay, it means period number 4 and 5 means 18 element each. If you talk about 6 and 7, so 32 element each. This we need to keep in mind, 32 element each. Getting, they are the characteristic. Now no, note is what? Okay, property, property, they are saying property in period. They are saying property in period gradually change. It is not same, it is gradually change. In period, properties are not going to be same. It is going to be change. So property in period gradually change. It's okay. Can I erase it? Can I go in the next page? Can I move to next page now? Are you listening?
Yes, sir.
Okay, good. Now, let's see the group. If you talk about the group, okay, group.
18.
So group 18 are there. There are, they are saying, there are 18 vertical column, 18 vertical columns present in this periodic table, present in this periodic table, in this periodic table. How many? 18. Known as,
Yes.
known as, what they are
Wow.
saying, known as groups. Groups. They have, they are saying, they have elements of similar properties. That is what the important point. They have elements of similar properties. Similar properties. But if you talk about the previously, here you see in the period here backside, what type of elements are there? You can see property in period gradually change. Means in the period property are not same. But in group you see
Yes.
they are saying they have elements of similar properties. Yes, yeah, no.
Yes, sir.
Yeah, this is the what the point. Okay. So this is the group. What we have to study the next one, after the group, we are going to study the characteristics of group. Here itself I am writing characteristics of group. Characteristics of group. So if we talk about the characteristic, there are some n number of characteristics are there. Okay, the first one. In particular group, they are saying in particular group, they have elements of, they have elements of similar properties. They have elements of similar properties. This is what the point. This is the first
Yes, sir.
characteristic. If I will ask you the second one, they are saying they have same valence cell configuration, same, not similar, same valence cell configuration. Valence cell configuration means valence cell configuration will be same. Third one, group valency is same for all elements. Group valency and oxidation number is same. Okay, this is what the point, okay, that you need to keep in mind. In particular group,
Yes.
they have elements of similar properties. They have same configuration. They have same valence cell configuration. Group valency and oxidation number is same. Is it okay?
Yes, sir.
Okay. Now let's try to move on the next slide. Here, if you see, that is the fourth point. What are the fourth point? Group 1 is, we have to study in this detail in S block. Group 1, group 1 and 2. Here better write. Group 1 and 2 are known as, what you are saying, group 1 and 2 are known as, what you will say, S block element.
S block elements.
Why they are known as S block element, Jaimanab?
I don't know, sir.
As the last electron, as the last electron is enters into s orbital, enters into s orbital. Okay, s orbital. Now see. Here, if I am going little bit detail, if I'm talking group 1, and here I'm writing group 2. So if you talk about the group 1, so what are there? Here you see linane, lithium, sodium, potassium, rubidium, cesium, francium. These are there, right? Here is beryllium, magnesium, calcium, strontium, barium. Last one is radium. Up if you can understand, here is 3, 11, 19, 37, 55, 87. Here if you are going this one, so how much? 4, 12, 20. I will tell you how to memorize this atomic number. Nothing you need to not to memorize. It is 56. There is the trick is there. And here is 88. Now, let's do the configuration. Do you know the electronic configuration, Janab? Can you tell me this one?
Yes, sir.
Hmm.
Sir, I know.
Hmm.
1s square,
Hmm.
1p.
No, 1s2 and 2s1. See, it is
Okay,
going
sir,
to.
I don't know electronic configuration. This type I don't.
Okay, okay. We need to atomic structure. No, we need to study atomic structure. In atomic structure, what is there? Above rule. In atomic structure, what is there? Above rule. AUFBAU. Above rule. So there, according to that, we need to study. So what we can do? Okay. Above rule, do you know, Janab? Above rule. Janab, do you know above rule?
No, no.
Okay. Let us little bit you understand this one, otherwise you will face the problem now. Okay, AUFBAU. AUFBAU. Above rule. Above rule, what it is saying? Electron field in increasing order of electron field in increasing order of energy of orbital, increasing order of energy of orbital. So what is the energy of orbital? How we can understand? So the see, here is 1s is there, then 2s and 2p. Next one 3s, 3p and 3d. Next one 4s, 4p, 4d and 4f. Here is 5s, 5p, 5d and 5f. Next one is 6s, 6p, 6d. And last one, if you are going 7s, 7p, this much only. So how the firstly electron goes? First electron enter into 1s orbital. Then where it is going to be 2s orbital. Then where it is going to be 2p and 3s. Then here you see only straight you need to go, very, very straight. If you are not going straight, it will be the wrong. Anything you are missing out, anything you are not supposed to change. Whatever the straight it is going diagonal is coming, the same you need to match with. So these are the order of the filling of orbital that is said by the above. Now next one is this one. Here is this one. Now see how you are going to fill. So first one is the going to be 1s, then it is the 2s, then it is going to be 2p. After that, which one will come? 3s, then 3p,
3p, 4s,
4s, then
3d,
3d,
4p, 5s.
5s. Next one is what is coming? 4d, 4d, then 5p, then 6s, then it is going to be 4f, 5d, 6p, then 5f, 6d. This much are there. Okay, so let's try to understand this one. So these are the increasing order of energy. Increasing order of energy. This we have to understand. Increasing order of energy of orbital. These are the orbital. Energy of orbital.
Yes, sir.
Okay, can you tell me S orbital maximum how many electron? 2 electron. P orbital
Two.
6 electron. D orbital
Hmm.
10 electron. F orbital how many? 14 electron. These are the very basic concept of atomic structure. If you are not knowing, then it is going to create the problem.
No,
Okay,
sir. Only this part I'm weak in atomic structure.
okay,
This
okay,
Forbes principle only I don't.
okay, no problem. So this, S orbital 2 electron, P orbital 6 electron, D orbital 10, F 14. Now let's go. So here is already we know 1s, then 2s, then going to be 2p, then 3s, then 3p, then 4s, then 3d. Now let us fill 1s2, 2s1. Here if you are going, it is going to 1s2, then 2s2, then 2p1. No, 2p6 and 3s1. Here it is going to be inside is same, and here will be 4s1. Okay. Here if you are talking about, here it will be everything will be same, 5s1. Similarly, if you go beryllium, it is going to be 1s2, then it is going to be 2s2. If you see 1s2, then 2s2, 2p6, and then now 3s2. Now see that they have same configuration or not. Here you see lithium is 2s1, s1 is coming. Here is 3s1, again s1 will come. Here is 4s1, s1 is coming. Here is 5s1, but that is s1 only. Here will be that is 6s1, that is s1. Here will be 7s1. So same balance cell configuration is same, isn't it? Is it or no?
Yes, sir. Yes.
So that is why they are known as this group 1 and group 2 are known as S block element. The reason behind there, the S block element is the last electron. See, that is last electron entering into S orbital. Is it? Can you see? No. Are you understanding or should I again explain?
Yes, sir. Understood.
Okay, okay. So here you see this one. So configuration, you please try to understand. Okay, if you are facing the problem, please tell me. I'll share some of the video I made on the basis of this one. So I will share you. You can once watch that one. Okay.
Oh, yes, sir. Please share.
Okay. So this is the group 1 and 2 we study S block element. Now that is we are going, that is P block element. So P block element, if you talk about, so what are the P block element? So P block element means the elements, if you define the elements in which last electron enters into p orbital. The elements in which last electron enters into p orbital are known as what? Are known as p block element. Is it okay? Are known as p block element. The element in which last electron enters into p orbital are known as p block element. Now they are saying p block element comprises of 6 groups. Here you see p block elements are comprises of 6 groups. Comprises of what? 6 group. P block elements are comprises of 6 group which are from group 13 to group 18, which are group 13 to group 18. Okay, now if you see that is group 13, okay, 13, then group 14, then 15, then here is 16, here is 17, and last one is going to be 18. What are these one? Group 13, they are known as, that is what is called boron family. Here is you are going to name boron family. If you see group 14, that is carbon family. If you have drawn the diagram, you will be able to understand this one. This is the nitrogen
Yes, sir.
family.
Yes, sir, I understood.
Ah,
Nitrogen family.
and here is, that is oxygen family.
Oxygen family.
Hmm. 17 is halogen family. This is halogen family. And lastly, they are the noble gases, or that is also known as inert gases. So these are there. They are known as, these all 6 group are known as what? P block element. Okay. If you ask that is why they are known as P block element, because last electrons are entering into p orbital, that is why they are known as P block element. Is it okay? Yes or no?
Yes, sir.
Now you see, I'm not going in the very detail. Otherwise, we can go in the very detail also. See, if I am going little bit detail, let me write that in 13, 14, 15, 16, 17, 18. How we memorize these groups if you talk about that one? Okay, memorization of each group is some no mnemonics is there, that way you can memorize. If you, but I know in Hindi only, I don't know in English. Okay, how our teacher taught us, that I know. Let me see this one. They are the 6 group.
Yes, sir.
They are the P block. Okay, so that is, here is the boron family. So boron, carbon, nitrogen, oxygen, fluorine, and neon. If you talk about boron, so how much? Bagan, aloo, gajar in thala, TL. So we memorize like that. Bagan, aloo, gajar in thala. Boron, aluminium, gallium, indium, thallium. If you talk about carbon, uh, here in the Hindu religion, they have the some name. Kahe Shivji, Sun Parvati. So carbon, silicon,
Yes, sir, I
germanium,
got it.
no, lead, and that is what? Tin and lead. Carbon, silicon, germanium, SnPb. Nitrogen, Nepal, Pakistan, Australia, sub Bimar. So how much nitrogen, phosphorus, arsenic, antimony, bismuth. Old style से टीपो, old style से टीपो. Oxygen, sulfur, selenium, tellurium, and polonium. Here is fluorine, फिर कल बाहर आई आंटी. Fluorine, chlorine, bromine, iodine, astatine. Here is the helium. So if you see, helium is little bit, it is going to be little bit away on the top, because this is belongs to first period. So helium here is there, neon, organ, krypton, xenon, and radon. These are there, right? So that way you can memorize this one. It will be very helpful for the 12th standard, because P block is there in 12th standard, and group 13 and 14 are there in the 11th standard. So on the basis of these, much questions come. Around 12 marks comes in the 12th standard in the board exam, and similarly that is around, I think that is the 4 question at least come from this one, periodic table and S block, P block. in the NEET exam also. So they are very, very important. You need to
Yes,
memorize
sir.
this one. Up
Okay,
now.
sir.
Okay, this much. If you talk about the group, simply you write that is D block element. If you see D block element, if I will write D block element, okay, how can we able to D block elements? Okay, so definition, if you want to write definition, the elements in which, what is the definition? The elements in which, the elements in which last electron enters into d orbital. D orbital is known as D block element. D block element. The elements in which last electron enters into d orbital is known as D block element. This is what the definition. The elements in which last electron enters into d orbital is known as D block element. That we have to keep in mind. So here is what are the, they are comprises of 10 groups. How many groups are there? They are comprises of 10 group. Comprises of 10 group. Okay. So what are 10 group are there? From group 3 to, from group 3 to group, how much? Group 3 to group 12. They are there, right? So they are the D block element. Let's have a look over the another one, F block element. F block element. So if you talk about
Sir,
F
F
block,
block is bottom wala block, right?
yes.
Okay.
So here is the, we can write F block element. There are two series, okay, two series of elements present in, they are saying present in down, down or bottom, you can write present in the bottom of periodic table, present in the bottom of periodic table in which last electron enters into where, that is F orbital. Last electron enters into F orbitals are known as what? Are known as F block element. Are known as F block elements. Can you understand this one? There are two series. There are two series of element present in the bottom of periodic table in which last electron enters into F orbital are known as F block element. So they are the, what is known as F block element. So they are, this is all about the long form periodic table. Now we have to understand the periodicity in properties. So let's try to understand periodicity in properties. What is meaning of this one? Periodicity in properties. So let's try to understand. Periodicity in properties means, periodicity in properties means what? Periodicity in property means the change in properties. The change in properties. Change in properties while moving down the group, 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 or while moving down the group, or change in properties while moving down the group or moving left to right or moving left to right in periodic table. Left to right in periodic table. So that is what periodic table in period, right? So if someone is asking what is periodicity in properties, so how can you be able to reply? So periodicity in properties means the change in properties while moving down the group or moving left to right in periodic table in period. Are you be able to understand this meaning of periodicity in properties? Yes, yeah, no.
Yes.
Hmm. So periodicity in properties means that is what we are saying. Periodicity in properties means the change in properties while moving left to right in periodic table or moving top to bottom in periodic table. So this is all about periodicity in properties. A names of properties. What are the names of properties? Okay, so first one, atomic radii. Atomic radii. Okay, atomic radii, or that is also known as atomic size. Both are the same. This is the first which we have to understand. Second one, metallic character. Metallic character. Next one, third one, non-metallic character. Fourth one, electronic configuration. Electronic configuration. You please keep in mind, if I will miss any of the point, you please remind me later on. Electronic configuration, valency, oxidation state, oxidation state. Seventh one, what is seventh one? After oxidation state, what will come if we talk about electronegativity? No. Before that, we will study the ionization energy, then electronegativity. 10 properties are there. Ionization energy, ionization energy, ionization energy. Okay. Eighth one, electronegativity, electronegativity. Okay, this is the eighth one. Ninth one. What is the ninth one? Electron affinity. Electron affinity. This is 9 properties are there. One more property is there. That is not important. We'll tell you that one. Okay. So first of all, what we are going to do, we are going to study. Here we are starting from the electronic configuration. We'll start from the electronic configuration first, then we'll go for the size. So let's try to understand that is first one. Okay. Variation of electronic configuration.
Okay, sir.
Hmm. Okay. So if someone is asked what is electronic configuration, so how will you will reply that is distribution of electrons in orbitals are
Yes,
known
sir.
as electronic configuration Okay. So if someone is asking what is the electronic configuration, means that is you have to tell that is how many electrons are distributed in the various orbital are known as electronic configuration. Okay, this is what the meaning of electronic configuration. Now just now I told
Yes, sir.
you that that is the in which orbital how many electron going to be present, right? Just now I told you the s orbital. If you talk about, so s orbital, if you see s orbital, so s orbital means maximum. I am writing maximum how many electron? 2 electron. Minimum can be 0. P orbital, if I will ask about p orbital, maximum electron how many there will be? 6 electron. If I am asking
6
d orbital,
electrons,
hmm, so
10
d
electrons.
10 electron. Thank you very much. So here is going to be 10 electron. If I will ask that is f orbital, so maximum electron if I will ask that is 14 electron. So these are there, right? Now, so variation there. Now we are going, that is variation. We are studying the case one. Okay, case one, case one. Variation in group. Variation in group. Very, very important. These are very, very important. So here what they are saying, on moving, what? On moving down the group, down the group in down
Down
the
the
group
group
in periodic
in
table, you can
period.
write in periodic table. On moving down the group in periodic table, valence cell configuration is same. Valence cell configuration is same. That is what very important. Valence cell configuration is same. Okay.
Group electron.
Hmm. So let's try
Yes,
to
sir.
understand here. Of any of the group, you take it out. Okay. I'm talking about group one. I'm having group one. So what are there? Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Right. So firstly, normal configuration I will tell you. Then I will tell you one is orbital configuration. See how the electron distributed. So the first orbit, first period, how many elements are there? Can you tell me? First period, how many elements? If you see period one means 2 element. Yes or no? If I will talk period 2 and 3, how many element are there? 8 element.
Sir. 8 elements.
Period number 4 and 5, how many element? 18 element. Period number 6 and 7, how many element? 6 and 7, 32 element. Just now I told you. Okay. Yes or no? Yes or no?
Sir. Yes.
Okay. It's getting too much, na? Whatever I'm giving you, Jana, please write down. Why not giving you time to write, because it will take too much time. It is
Yes,
going to
sir.
Hmm. So whenever you are getting time, please you write down this one. If you are not writing, this is it will be waste, not useful. Getting my point. So you need to write somewhere. So whenever you are getting time, you please keep on writing, right? So here, if you see, so this is belongings to period number 1. Lithium belongs to period number 2. You can see the previous day notes it is there in your mobile also. I draw on this one. Period 1, that is hydrogen. Period 2, lithium. If I talk period 3, sodium. Period number
Yes.
4, potassium. Period number 5, rubidium. Period number 6, cesium. Period number 7, that is what is there, francium. So here, if you see that this is the first element, so automatically its atomic number is 1. Okay. So if you want to go lithium, so what will go? That is how many elements are there in first period? 2. Yes or no? Tell me. First period 2 element or not?
Sir. Yes.
No, you are very much confused. See,
Yes, sir. Now I'm confused.
see first period. Characteristics of group. Where is the period? Period. No, characteristics of period I wrote somewhere. I think I erased out. No, not erase. See, period 1, shortest period. How many element? 2 element.
Two
2 and
elements.
3, short period, 8 element. Period
Eight
4 and
elements.
5, 18 element. Period
18
6 and
elements.
13, 2 is 32.
32
So that is
elements.
same. So period number, if you see 1, how many element? 2. So I am adding 2. So if you are adding 2 in this one, so automatically it will come 3. So 1, 2 over. Then if you are going, that is period number 3 and 4. How many elements are there? Period number 3. 3 and 4, 8 elements. Yes or no?
Yes, sir.
So I am adding here plus 8. So if you are adding plus 8, that is 8, 3, 11. So atomic number of sodium. If you are adding, that is, here is again 8, because fourth period also 3, no, 2 and 3, same number. So in third period, if you are adding 8, so it will come 19. Then you have to add, that is plus 18. So if you are adding 18, so it will come 37. Again you need to add 18. So how much will come? It will come 55. Again you have to add 32, so it will come, that is 87. So this way you need to memorize, right? 2 element, then second and third period 8 8, 4 and 5 element 18 18, and 6 period 32. Getting my point? Are you be able to understand this atomic number, concept of atomic number, how to memorize?
Yes.
It will be tough. It will be tough. Slowly, you have to think on it. Okay. So that it will be. So let's see. This is how I wrote the atomic number. If you talk about the second period, see, beryllium, second group, beryllium, boron, carbon, no, beryllium, after beryllium, magnesium will come. Beryllium, magnesium, aluminum, no, beryllium, magnesium, calcium, strontium, okay, beta mange car, scooter, bap, raji, okay. So simply after lithium, beryllium will come now. So the lithium, beryllium, so 4, sodium, magnesium, 12, 20, 38, 56, 88. So I know the atomic number of all the element. Okay, I didn't memorize, but while the trick applying, it's get easily understood for me. Now see the configuration here. I'm writing, that is lithium, sodium, potassium, rubidium, cesium, francium. Here is 3, 11, 19, 37, 55, 87. So how much will be there? See, 2 and 1. Okay. A
Yes, sir.
Bohr-Bury model, if you are knowing, then only it is helpful. Atomic structure is very important. 2, 8, 8, 1. Here what will be there? 2, 8, 8, 18, and 1. Here you see 2, 8, 8, then 18, then 18, and then 1. Here you see 2, 8, 8, 18, then 18, then 32, and finally it is going to be 1. This is how the configuration is going to be takes place, right? That you need to memorize. Okay, let's do the orbital configuration. So if you are going 1s2, then it is going to be 2s1. So here is, this is the s1. If you see this one, it is going to be 1s2, then 2s2, then 2p6, and last one it is going to be 3s1. You can add out, same will come. Here if you are 1s2, then it will come 2s2, then it will come 2p6, then what is 3s2, 3p6, okay, 4s1. So see, everywhere it is coming s1 s1. Here what will come? Here 1 is there now, so it is going to be, everything will be same. It is the 6 no 5s1. Here is, it is the
Yes, sir.
5s1. If you are going for this one, so it is going to be 6s1. If you are going for this one, so it is going to be 7s1. Yes or no?
sir.
So what I said you, the balance cell configuration is same in the group. Yes. Yes, yeah, no. See, S1, 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 S1. Yes, yeah, no. Yes, yeah, no. Tell me.
Yes.
Okay.
Yes.
Okay, good, good. Thank you. Acha, tell me, Janab, how many orbits are there? You see, orbit. So here is this is K and this is L. Bohr atomic model, if you are knowing. So this is K and
Yes,
L.
sir.
So that is how many orbit? Two. If you talk about sodium, how many orbit are there? Can you tell me? So this is the K, this is L, this is going to be M. Bohr's atomic model. So that is three orbit. So three. If you talk about this one, how many orbit will be there in this one potassium? Tell me. See,
Yes, sir.
K, L, M, and N. Very tough. For beginning, it is very tough. I am going little bit faster. So how many are there? K, L, M, N. So that is four.
4.
If you are going for the rubidium, this one. So number of orbit, if you are looking for, how many will come? 5. If you are going for this one, cesium, so how many orbit? This is going to be 6. Now the francium, if you are going this one, so how many orbit will be there? 7. Can you understand this one number of orbit? Yes or no?
Yes, sir.
Okay. I think network issue is there your side. Is it clear? Is it clear? Up to here is
Yes, sir.
clear?
Yes.
Okay, thank you very much. Now, up C, that is the very much I am dealing here. The second characteristic. Electronic configuration is group is valence cell electronic configuration in group is C. Here, now. Atomic radii. See the atomic radii. What is atomic radii, Janab? Can you tell me?
The radius between the shells.
Good, good. The distance between, okay, you are saying quite okay. The distance between nucleus, the distance between nucleus and outermost orbit, outermost orbit. The distance between nucleus and outermost orbit is known as atomic radii,
Yes, sir.
is known as atomic radii. So here what is there? This is the nucleus. And here is what is this one orbits are there. Suppose this is a orbit outermost electron. So what we are going to say, the distance between nucleus and outermost orbit, this is known as RA, R for radius, A for atomic. So this is what the radii, this one. Here what we can name this one, this is the name is atomic radii. Atomic radii. Yes or no? Are you be able to understand this?
Yes, yes.
Okay.
Yes.
Uh, Variation of atomic radii in group. Variation of atomic radii in group. You didn't send the exercise problem from your book to me.
I took PDF. I forgot to send. I'll send, sir.
Okay. So this one you see little bit. So see, if you are going, that is suppose lithium, sodium. I'm making this one. Okay. The space is less, na? That is the problem. So here is the lithium, sodium, potassium, rubidium, cesium, and francium. How many orbit was there? 2 orbit. It was the 2 orbit. 2 orbit means 2 cell, 3 orbit. Here is 3 orbit. Here is 4 orbit. Here is 5
Yes, sir.
orbit. 5 orbit. It was having 6 orbit. 6 orbit. Here is 7 orbit. That already I discussed you here. Okay, here is that 3, 11, 19, 37, 55, 87. So make it. So if you making the lithium, you will find that is 2 orbit. Yes or no?
Yes,
This
sir.
one. Sodium. If you see sodium, how many orbit? That is 1, 2, and 3. So then potassium. So 4 orbit. 1, 2, 3, and 4. And if you are going rubidium, so you see 1, 2, 3, and it is going to be 4. So Janab, if you are moving down the group, what is going to happen? Size increasing or not? Atomic radii increasing or not? Tell me.
Increasing.
Atomic radii down the group increases. Down the group increases. Why? Atomic radii down the group increases due to increase in what? Due to increase in number of orbit. Number of orbits. So down the group, what is happening? The number of orbit increases. So distance between nucleus and outermost cell automatically will increase. So down the group, atomic radii is increasing or decreasing? What is happening?
Increasing.
Thank you very much. So आज के लिए today we are doing this much only because I think you may be tired of listening 1 hour
Yes, sir.
completely. So
Yes.
I'll
It's
share you
confusing,
this
sir.
PDF. I'll share you the PDF this one, and you also share the problems from your book also. So I will try to do. Okay.
Yes, sir, sure.
Okay.
Sir,
Okay.
can you mean like send me the 4 pics
Which
PDF?
this one, na? This one, what I wrote, na?
Yes, yes, yes.
100%, 100%, 100%. I'll send. Okay. 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 Bye. 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 I'm taking the pic. I'll share.
Yes, sir.
Hmm. Oh, my God.